Hello, students. Stay happy, stay healthy. In this lecture, we are going to discuss the topic second type of nucleophilic substitution, that is SN1. What is SN1? Unimolecular. This one represents unimolecular nucleophilic substitution reaction is called SN1. Generally, it is given by tertiary alkyl halide. In the last class, we discussed SN2 reaction is given by primary alkyl halide, secondary, then tertiary, right? So now we are going to discuss about SN1. SN1 in SN1 reaction, tertiary alkyl halides will give SN1 reaction. The reaction you see, this is the tertiary alkyl halide. All are methyl groups present over here, tertiary alkyl halide. When treated with a water, here water is acting as a nucleophile. Tell me, in any reaction, if water acts as a nucleophile, what that reaction is called? What we call that reaction? That reaction is called solvolysis. In any reaction, if solvent is act as a nucleophile, then it is called as solvolysis. So here Cl is replaced by OH group. Let's see the mechanism, how this reaction is taking place. The SN1 reaction is two-step nucleophilic substitution reaction involving a carbocation intermediate. Sir, what is this, sir? Why like this? Not understood clearly. SN2 reaction, you said there is no possibility of front side attack. That's why nucleophile attacks from the back side. But here in SN1 reaction, why, sir? In SN2 reaction, backside attack is possible, whereas in SN1 reaction, because of tertiary alkyl halide, front side attack is also not possible, and backside attack is also not possible due to what is the reason? Tell me the reason. The reason is steric hindrance. Due to steric hindrance, it is backside attack also not possible. That is the reason SN1 reaction is carried out in two-step reaction involving a carbocation intermediate. So the rate determining step is the formation of carbocation. In this, rate determining step is formation of carbocation. We'll see how it is happening. In the first step, the carbon halogen bond of tertiary butyl bromide slowly breaks heterolytically and it forms intermediate carbocation. See here, students, clearly. So in tertiary alkyl halide, first step is this bromine is going out. As a result, carbocation intermediate is forming. The carbocation intermediate is forming. This is a very slow step. Slow step of the reaction is called what? Rate determining step. Slow step is called rate determining step. Now step 2. In this reaction, you see rate of SN1 reaction. Tell me, in the above reaction, is there any presence of nucleophile? Does nucleophile is determining any speed of reaction here? Huh? Is there
No,
any work of nucleophile here? Is
no,
there
sir.
any role?
No, sir.
No. There is no role of nucleophile here. That's why the rate of SN1 reaction depends only on the concentration of alkyl halide and it is independent on the concentration of nucleophile. Rate of reaction is directly proportional to concentration of alkyl halide only. That's the point. Next, in step 2, what is happening? The formed carbocation rapidly react with nucleophile. Then OH minus nucleophile, that is, it gives tertiary alcohol. See this? The once carbocation formed, OH minus can attack from any one side, either from this side or this side, any side it can attack and forms alcohol. Clear? So remember always generally what it is in a at a glance we'll discuss. SN1 reaction is given by tertiary alkyl halide. So in tertiary alkyl halide there is no possibility of front side attack. Front side attack not possible because of repulsion. Back side attack also not possible because of bulky groups. So nucleophile attacks not possible. Therefore, no effect of nucleophile. So what is happening? Being a tertiary alkyl halide, step 1, what is happening? Carbocation intermediate is forming, and step 2, nucleophile is attacking on carbocation. This is the concept of SN1 mechanism. Next, the energy diagram. This is the most important thing, the energy diagram. See carefully. Initially reactants are present. Tertiary alkyl halide reactant is present. That reactant involves in transition state 1. This is transition state 1. What is happening first? The bond between alkyl group and bromine is breaking. Bond between carbon and halogen is breaking. After the bromine moves away, then carbocation intermediate is formed. Right? Now this when compared to the transition state, intermediate energy is less. That means stability of intermediate is more when compared to the transition state. Then what is happening after the formation of carbocation? Carbocation is sp2 hybridization and it is planar in structure. So what is happening? Nucleophile attacks immediately. Nucleophile is attacking. That H2O solvent is there. Slowly it is approaching to the carbocation. So the bond between carbon and nucleophile starts forming. After some time, the carbon and oxygen bond is formed and the products are formed with less energy. This is the overall energy diagram. The basic question they may ask, how many transition states are present in the SN1 mechanism? How many transition states? Right? Then here we'll see step 1, ionization, that is slow and rate determining step. Step 2, carbocation intermediate formed, sp2 hybridization. It is very reactive and that's the intermediate. And in step 3 what is happening? It is not step 3, just point 3. Nucleophile attack takes place on the carbocation. Then ultimately removal of proton forms a neutral product alcohol. This is the overall energy diagram of SN1 reaction. Next, characteristics. Rate of reaction is directly proportional to what we discussed already, concentration of alkyl halide. Which alkyl halide? Tertiary alkyl halide. Rate of reaction is directly proportional to concentration of tertiary alkyl halide. So that's why the power is 1. So order of reaction is 1. Only one reactant molecule is involved. So molecularity is 1. Got it? Next. Characteristic number 2. Rate law. The rate of reaction is only sensitive to the concentration of substrate. The same point again. See the graph between rate and concentration of reactant, it is directly proportional, so the graph is coming in this manner. But if you see rate with concentration of nucleophile, this is what? Nucleophile. This is the nucleophile. With nucleophile, the graph is coming a straight line. Graph is a straight line with nucleophile. Why straight line? Because rate of reaction is independent on the concentration of nucleophile. So we can say from this, the conclusion is there, with respect to reactant molecule, it is a first order reaction. With respect to nucleophile, it is zero order reaction. Clear? Then rate is overall reaction is first order. Very good important point it is. With respect to, say, they may ask question with respect to what is the overall order of reaction of SN1, anyone can tell. To make you confuse, if they ask what is the order of reaction with respect to nucleophile in SN1, will write, everyone will think SN1 nucleophilic substitution. So definitely nucleophile role is there. So it depends. First order will say, but in SN1 there is no role of nucleophile. It is zero order. That's the concept behind this. Next, order of reactivity towards SN1. See here again, don't get confused. Whatever it may be, either it is SN1 or SN2, the order is same, because this
Sir,
order depends on what? Nature of leaving group. This order depends on nature of leaving group. So here in SN2 as well as SN1 also, the order of alkyl halides are same, because it is depends on the nature of leaving group, not on the nature of alkyl group here. That's why both the cases alkyl iodide is the highly reactive. Next point, rate of reaction depends on stability of carbocation, which is more stable. Tertiary carbocation is more stable. So rate of tertiary alkyl halides undergo very highest rate of SN1 reaction. Next, if alkyl halide is chiral, again came optical isomerism. If alkyl halide is chiral, then racemic mixture is obtained. What is that? You know, suppose we'll see the example here. Then we'll see. This is the alkyl halide, very beautiful alkyl halide we have. Second step only. This I have written only step 2. Step 2, formation of carbocation. This is the stable carbocation formed, right? This is the chiral substance. See, different groups. Green is different group. This is different group. This is different group. This is different group. 4 different groups are present. In that, the bigger group, it is moving away. The leaving group, let us assume it's a leaving group, has gone. Then what it forms? Carbocation, sp2. Planar shape came. Now, the nucleophile can attack from this side as well as from this side. So, if it is attacked from left side, the incoming nucleophile position is this. If it is attacking from this side, incoming nucleophile position is this side. So, in a chiral center, if it is a chiral center, definitely inversion and retention are taking place. Inversion, retention taking place. See students, here I said 50% of inversion and 50% of retention. This is not exactly true. This is not exactly true. Generally, inversion configuration is little bit higher than retention configuration. Inversion configuration is slightly greater than retention configuration. In the question, if they ask, another question that there is, what is the major component in SN1 mechanism? Inversion or retention or equal? None of these. Definitely you can say inversion is slightly greater than retention. Inversion is slightly greater than retention. You have to say this. Understand? So they, by calling it is racemic mixture, but 100% pure racemic mixture, it's won't possible. Generally, inversion configuration is slightly higher than retention configuration. Next, characteristics, another one. Following compounds won't give SN1 as well as SN2. Neither SN1 nor SN2. Both it won't give. What is that? First one, alkyl fluoride. We discussed what is the reason for alkyl fluoride. The bond strength between R and F very high due to more strong bond. It is difficult to break with any nucleophile, so it's not possible to break. Second one, vinyl halide, never and never on the double bonded carbon. No nucleophilic substitution can take place. Aryl halide, same story. On the double bonded carbon, neither SN1 nor SN2 is stable. Now you may ask doubt, sir, in vinyl halide, if I try to do SN1, X will go, vinyl carbocation is formed. So this vinyl carbocation is stable. Is it stable, right? Highly. What it is? Highly unstable. Never it is. That's why there is no nucleophilic substitution. And see here, in this case also, if X is going, phenyl carbocation is formed. But do you anyone with minimum basic common sense, if they have, do they say that phenyl carbocation is stable? Do they say phenyl carbocation is stable? No, phenyl carbocation is never it is stable. In those two, that's why it won't come. Next, halogenate bridgehead carbon. The bridgehead carbon in SN2 reaction we discussed. At bridgehead carbon, backside attack is not possible. Backside attack is not possible because of this big one. And front side attack is also not possible. Now tell me students, tell me at bridgehead carbon, can the carbocation is existing? Do the carbocation existing at bridgehead carbon? No, it never exists. No, carbocation never exists at the bridgehead carbon, right? So at bridgehead carbon, positive charge never exists. That's why this reaction is also not possible. Next, compare rate of SN1. Compare rate of SN1. Solve the question here. What would be the answer? Rate of SN, whenever you see the rate of SN1 in your brain, one point has to come, that is rate of SN1 is directly proportional to stability of carbocation. Stability of carbocation.
Sir, 2 and 3, 2, 1, 4.
Highest is, the answer is 3 greater than, 2 greater than, 1 greater than 4. More stable carbocation is 3 because of more resonating structures. If it is coming here, right, more RS will be there. After that, 2 allyl carbocation will form. If Cl will go allyl carbocation, it is stabilized by resonance. Then it is with 4, what is happening? Phenyl carbocation. Just now we discussed phenyl carbocation is highly unstable. So that is the order 3, 2, 1, 4. Clear? Next. The stability of carbocation again. Try this. Bromine is moving. positive charge comes here, bromine moves, positive charge comes here, bromine moves, positive charge comes here, and NO2 nature is electron withdrawing group, OCH3 nature is
Sir,
electron donating
312.
group, electron donating group. So in the presence of electron donating group, stability of carbocation, electron donating group is directly proportional to stability of carbocation. So let's see here. The answer is 3 greater than 1 greater than 2. Clear answer?
Yes, sir.
Next question. Try this. If Cl is going here out, then positive charge formed here. If Cl is going there, positive charge formed. Cl is going out, positive charge formed. In this case, first case, that carbocation is stable due to plus R effect. Here oxygen is showing plus R effect. Whereas in this case, oxygen is showing a more minus I effect because positive charge not in conjugation with oxygen. It is not in conjugation. If it is in conjugation, oxygen can show plus R. But once there is no conjugation, it shows minus I. And here also it shows minus I. So where is more minus I? More minus I is present in second structure. So that is the least stable. So answer will be 132. Very good. 132. Next question. Very easy, you can say. In both
1
the
greater
cases,
than 2.
yeah, Cl is going, the positive charge forms here. From here, Cl is going, positive charge forms. And in this case, first one is what? Aromatic. Aromatic, this is non-aromatic. So obviously, aromatic is more stable carbocation. Next, 1 greater than 2, answer. Another question, Cl and Br, which is highly reactive.
Second one.
Second,
Beer.
yeah. OH minus 1 molar, OH minus 2 molar.
Same.
Here you see, rate of reaction is independent on concentration of nucleophile. For SN1, we discussed already, SN1 rate is not at all depends on the nucleophile concentration. So if it is 2 molar or 10 molar or 100 molar, whatever it may be, the both are same, right? 1 is equal to 2. Next structure. Next structure, H2O 100%, H2O 80% and 20%. It is polar protic solvent or polar aprotic solvent. This question purely depends on polarity. Answer is 1 is greater than 2 because polar protic solvent. Water is more polar protic solvent. Next question. OTS is leaving group only. OTS is a good leaving group. It
2
is
greater than 1.
2 greater than 1. Why? Because 6-membered ring carbocation is stable as compared to the 3-membered carbocation. 3-membered carbocation are unstable due to angle strain. Next. Next, substrate SN1, SN2. CH3Cl can undergo SN1 or SN2.
SN2.
CH3Cl is SN2. Correct. SN1 not possible. What about CH3, CH2Cl?
Both.
SN2. Never. CH3, CH2Cl undergoes SN2 only. CH3F?
Both not.
Both are not possible. Next, tertiary alkyl halide is giving
SN1.
SN1. Secondary alkyl halide
SN1. C2.
SN1 is possible in the presence of weak nucleophile. This is secondary. And SN2 is possible in the presence of strong nucleophile. Like if you say weak nucleophile, example H2O, neutral nucleophile. Strong nucleophile example, you can take OH minus. Like depend on the nucleophile, the reaction takes place. Next, vinyl halide. This one,
Both not.
both are not possible. Here, allyl carbon is there.
SN1.
SN1 more stable, and moreover, it is primary too. This is primary also. Here, both are possible. SN1 is also possible. SN2 also possible. Next, benzyl. It is also primary.
SN1.
SN1 due to more stable benzyl carbocation, and SN2 is possible because of primary alkyl halide. This one is primary SN1 or SN2.
SN.
Here you see the structure OCH3 CH2Cl. Suppose if Cl is going out, carbocation formed, it is stabilized by the adjacent lone pair plus R effect. So SN1 is also possible. As a result of primary, SN2 is also possible. The same type of reaction is happened in the case of ammonia lone pair also. Positive charge comes here, it will donate the lone pair. Resonance plus R effect is there. So here also SN1, SN2 both are possible. In this case,
Both.
if positive charge,
SN2.
SN1 is possible here. Do
No,
you
sir.
think SN1 is possible there?
No, sir.
Why SN1 is not possible?
No conjugation.
No conjugation. See students carefully. SN1 is not possible there. Where it is? It is SN1 is not possible. Next here with this, SN1 is possible
SN1.
due to dancing
SN.
resonance. SN2 also
SN2.
possible. Over. Our SN1 reaction is completely over. So in upcoming class we'll discuss about applications of SN1 and SN2. Keep learning, keep growing, keep like, subscribe and share the chemistry sir, IIT JEE, NEET classes. Thank you students.